Okay, so we're going to look at the difference between direct variation and partial variation. Okay, and they give us two equations, and they don't seem to be related, but they're actually extremely related. And the reason they don't seem related is because they, for some reason in your book, write them as different letters. But we're going to clarify this. So partial variation is with this formula here, and this is technically the equation of a line, a linear equation. M is our slope. And this B stands for the y-intercept, and we'll kind of get into that. K is actually the exact same thing as M. It's the slope. So instead of calling it K, and probably in your books they're going to call it K, we're going to call it M because they actually represent the exact same thing. The only difference is in direct variation, there's no B. There's no y-intercept. And at least there's no variable for it. There technically is one, and we're going to talk about what it is. Okay, so we scroll down, and this is an example of a graph that's partial and a graph that's direct. Okay, and let's talk about direct first. Direct variation. Okay, so here's our y and here's our x. Direct variation always goes through the origin, so the point of 0 and 0. So what that actually means is our y-intercept. Okay, and the y-intercept is where we cross our y-axis. You know, cross here, here, here. With direct variation, you always cross the y-axis at 0. So direct variation, the b value that we don't really talk about is plus 0. And we don't have to write in the number 0, so that's why they don't put anything there. So with direct variation, they give you this formula. But really, the y-intercept is the number 0. The best way to remember it is it always goes to the origin. Partial variation is anything other than direct. So you cross the y-axis at any other point. So there's tons and tons of examples of that, right? Maybe this is the number. Oh my God. So I can start at any point. So for instance, in this example, let's just say it starts at the number 20. Okay, so we'll say that this is 20. So in this case, our b is actually the number 20. Okay, now the m in front of our variable x is what's considered the slope. So kind of the angle that this is on, and we're going to kind of figure that out as we go. Okay, but essentially partial is where it crosses the y-axis anywhere but 0, so it can't cross at 0, and direct is when it crosses at 0. Okay, so let's say we've been given a chart like this, and these happen to be set up properly, where this is a partial variation and this is a direct variation. What we have to figure out is our independent and dependent variables. So maybe this is a car mechanic, okay, and this is what he charges. So this is a car mechanic, and at 0 hours, so for him to just look at your car, it costs you 20 bucks. And then from there, 1 hour costs you 30 bucks, 2 hours is 40, 3 hours is 50, 4 hours is 60. We can use this to help us find the slope. The slope is the amount this is going to change by, okay? In direct variation, let's say you're buying things. Maybe you're buying apples. Okay? If you buy 0 apples, you pay $0. Nobody charges you not to buy an apple, right? If I buy 1 apple, 50 cents. 2 apples is $1. 3 apples, $1.50. 4 is $2. And again, we can find out the slope. We already know the y-intercept is 0, just like the y-intercept is 20 for our partial variation. So the way we can find the slope, there's actually two ways we can find the slope here. Assuming it's linear, okay, and I've drawn what's linear here, you just have to find two coordinates. So have they given you a formula like this to find slope? y2 minus y1 over x2 minus x1? No? Okay, we won't talk about that yet. What we'll do instead is we'll find first differences. And first differences tell us if something is linear. So we take the number on the bottom and subtract the one on top. So these are our y's, and these are our x's. Okay. These are our independents, and these are our dependents. So we subtract our dependents. So 30 subtract 20 gives us 10. 40 subtract 30 gives us 10. 50 subtract 40 gives us 10, and 60 subtract 50 gives us 10, right? So because they're all the same, we know it's linear. If they're all the same, that means we have a straight line, okay? And what this is actually telling us is the slope of the line in this case, just because this is changing by 1, 2, 3, 4. Okay?
So that means it's like going up by the same amount.
Yeah, it's going up by the same amount. So technically in this one, the slope is 10 and the price is 20. And I should have used the actual colors. I don't know why I chose to use different ones. Let's do that. Okay, and the y-intercept is 20. In this one here, we can do the same thing. 0.5 subtract 0 is 0.5. 1 subtract 0.5 is 0.5. 1.5 subtract 1 is 0.5. 2 subtract 1.5 is 0.5. So because all of those are the same, it's linear, so we know we have a straight line. And because it's all going up by 1, this only works when they're going up by 1, this happens to be the slope. So our m is 0.5. So we've kind of built the equations. This equation reads y equals 10x plus 20. That's partial variation. And this one reads y equals 0.5x. And this is direct variation because the y-intercept is technically 0. So this formula here is slope. And what slope is that variable that we briefly talked about, that m, the one that's the same in both, m. And it equals so many things. So I'm going to write them all out in a row here. It's going to look really confusing, but we're just going to focus on a few. So this formula equals slope. Slope is equal to m. M is equal to the change in y over the change in x. They use a triangle to represent change in that. And that's also known as the rise over the run. So I wrote a whole ton of things that you don't have to memorize any of this. But it helps us find that number m really quickly. We only need 2 coordinates to do it. Okay?
So now words are being incorporated into math?
Yeah, there's tons of words in math. Math is like a language. So let's talk about m. Okay? M is equal to the rise over the run, which is the change in y, which is y2 minus y1. So let's just say that m is equal to this formula. Okay? And this is the only thing we kind of need to memorize for right now. Okay? This, to solve, we need 2 coordinates. So we need any 2 points along the line. Any. So it would be this one and this one, or this one and that, and blah, 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 or these guys, whatever you want. Here, I've actually written out a whole list of coordinates. When you have a table, technically, these sets are all coordinates, okay? So we're just going to take a pair of them and use them, okay? So I'm going to choose all of this guy.
Wait, this formula works for both partial and direct?
Yeah, works for partial and direct.
Okay.
Okay. I'm just going to choose 2 random points. You could have chosen any 2 you like. I'm going to choose 1 and 30 and 4 and 60, okay? So 1 and 30 and 4 and 60. Now, which number 1 is an x or a y coordinate? What does that represent? The x value or the y value of that coordinate?
X, I think.
Yeah, x is always the first one, which makes this, by default, y. And therefore, 4 must be x and 60 is y. So we technically call these 0.1 and 0.2. Again, doesn't matter which one you call which. I'm going to call this guy 1, which would make him x1 and y1. And if we call him 2, that's x2 and y2. So now we have numbers that can go into this formula. So let's try to set this up. M equals y2, right? Well, y2 was the number 60. So 60. Subtract y1. Well, y1 was 30. Divided by, let's do this a different color, purple maybe. X2 was 4. Subtract x1, which was 1. Okay, so I've taken those 2 coordinates and I've put them in. Now we just kind of do BEDMAS here. 60 minus 30 will give us 30, and 4 minus 1 will give us 3. So m is equal to the number 10. And if you remember, that's what we found out when we were doing here, and that was the m value we originally found out. But what's really important also is, remember, we had hours and money, right? Well, we said hours was our x. Okay, we said hours was our independent variable, so that was our x. And money was our y. It was our dependent variable. So if you guys recall, I said slope was the change in y over the change in x. So if we're going to give units to this, okay, we would say it's dollars over hours. So I do the y is dollars, over x, and x was hours. So our m is $10 over hours. But how do we normally say that if we're talking about like paying somebody? We would say dollars. What would we say instead of over or divided?
Per hour.
Per hour, exactly. Okay, so we say it's $10 per hour. That's what that idea is. Okay, I'll quickly do the same example over here. I'm going to choose two random points. I'm going to choose zeros because I make it really easy. And 1. Okay, so we had 0 and 0, and 1 and 0.5 makes this. I'm going to make this guy x1 and y1. Okay, just to show you that it doesn't really matter. Okay, x2 and y2. So when I plug it in, y2 starts. So I go m is equal to 0, subtract 0.5 over 0, subtract 1. That gives me negative 0.5 over negative 1. Anything divided by 1 is the number on top, and a negative divided by negative is a positive, so I get m is 0.5, which is exactly what we found when we did this before. Okay. Sorry, let's go back up one more time. And remember, it was number of apples and dollars, right? So dollars was our y, and the number of apples was my x. So we say dollars over apples, right? So we'd say m, or it's equal to $0.5 over, I'm going to say, I'm going to use that symbol for apples, okay? Dollars over apples, or what would we say? We'd say it's $0.5
Per apple.
per apple, right? Or 50 cents per apple. That's what I
They
do.
usually go by pound now.
Probably. It would make more sense.